Hey, what's up everybody? This is the Helpful Hacker, and today we are going to be going over the Networking Secure Protocols room from TryHackMe. So we'll jump right in and get started with task number 1, the introduction. So basically, this is just going to give us a quick intro, and it's going to let us know, hey, you need to have done the Networking Core Protocols room. In fact, it's actually recommended that you have done all 3 of these rooms prior to doing this one. That way you have some base knowledge that we're going to build on. If you haven't done those rooms, you should pause this video, go check those out on TryHackMe. If you need help getting through those rooms, I have full walkthroughs of all 3 of those rooms on my channel, so you can find that there. And once you've done all that, you can jump right back into this room. So assuming you've done all the prereqs, what this room is going to do is it's going to add to our knowledge of protocols. So we should have already learned about some protocols, and they have those listed here. Now, what this room is going to talk about is it's going to talk about TLS, which stands for Transport Layer Security. And what that does is it takes these insecure protocols and it makes them secure. And that's what the S stands for here. And you can see we're just adding an S to the end, and now it stands for secure. So it's the secure version of these insecure protocols. Now, what makes a protocol secure or insecure? It's simply whether or not it's encrypted. So these protocols encrypt all of our data as it flows through a network. These protocols do not. So if somebody intercepts something, like let's say we, send somebody a message and we put our credit card number in there or something because they need it, right? If we're using one of these protocols and a third party were to intercept that message, they could read the credit card number. But if we're using one of these protocols, even if they manage to steal that message, they still can't read it because it's all encrypted. So that's what TLS does, and that's kind of the difference between secure and non-secure protocols. And then down here, they give you a note to let you know that Telnet is an insecure protocol, and today SSH, or Secure Shell, has replaced that. So nowadays, nobody uses Telnet. We all use SSH for stuff. So keep that in mind. And then the learning objectives for this room, basically, we're just going to learn about TLS and secure protocols, and then we'll learn a little bit about VPNs and SSH. So once you've read through all that, you can mark this complete, and with that you're done with task number 1. Now it's on to task number 2, TLS, and basically this is going to give you, this whole top part is just going to give you a background into TLS. But this quick version is, when we started networking and using computers, none of our protocols were secure, and then eventually someone was like, hey, we should probably do something about this. So they created something called SSL, which is the secure socket layer, and we went through a couple versions of that, and then eventually we created something called TLS that was better, so that replaced SSL. And since we've created it, we've gone through multiple versions and we've upgraded it. And so just read through that, you'll get a basic idea of kind of the history of how we got to using TLS. And then this is just a quick blurb about TLS. So it's a cryptographic protocol. And as I said earlier, it ensures that no one can read or modify the exchange data. So the data that we send on the network, even if somebody manages to take a look and actually see the data being sent, they won't be able to read it and they won't be able to modify it without the person on the other end receiving it knowing that it was modified. And it does this cool stuff for us, and it uses cryptography to do that. So lots of protocols have received security upgrades with TLS. They give you some examples here. And so what's cool about that is TLS works within the OSI model, so we didn't have to change much. Like, we didn't have to change the model. We could just add TLS to stuff, and then it was secure. And then they go into some technical background about TLS. So there's this thing called the TLS handshake, and they aren't really going to go over that, but we'll get to see, and I'm not going to go over it either because you'll see it and I'll show it to you with some web traffic, and you'll get an idea of kind of what it is. But just think, it's very similar to the three-way handshake, but instead of the three-way handshake is basically two computers saying like, hey, are you there? Yeah, I'm here. Great, let's talk. And that's how they start a session. The TLS handshake is similar in a way. It's kind of like, hey, can we make sure that nobody else can like read our stuff? Can we do this securely when we communicate? And then the other computer's like, yeah, sure. And so super basic version of the TLS handshake, but we'll look at that more as we go through the room. But what they do talk about here is they talk about certificates and certificate authorities. So basically, if a server or a client needs to identify itself, it has to get a signed TLS certificate. And generally the way it does that is it submits what's called a certificate signing request, and it gives that to a certificate authority. And a certificate authority is basically like this trusted third party that we all trust, we know, and they go through the effort to make sure that a server who says it's a server for Google, for example, they go through the effort to verify, oh, this is an actual server from Google, you can trust it, and when it says it's a Google server, it is. And so that's what the certificate authority does. And they verify it, and then they issue a digital certificate with their signature. Okay? Now, it's not a literal signature, it's a digital signature. If you don't know what that is, don't worry. Just to kind of get a basic understanding, you can honestly kind of think of it as a legitimate signature. But just don't take that too literal, but because it's a digital one. But you'll learn more about that as you go through TryHackMe and learn more about cryptography and how that works. So what this certificate that has been signed by the certificate authority does is it lets everybody else know, hey, I'm legit, you can trust me. Like, if you communicate with me securely, don't worry, I'm not gonna say anything, and no one's gonna be able to read the stuff that we, send to each other. So that's what certificates do. And you can read more about them here. If you want to know more details, you can Google it. TryHackMe has several rooms that go a bit more in depth, such as the networking security protocols room. They'll tell you more about the TLS handshake for sure, and they also talk about certificates. So let's see, what else do they bring up here? So this is what it looks like in a web browser. So the screenshot shows the trusted authorities installed in a web browser. So I don't think you have to worry too much about this, but basically, in order for a host to decide, hey, is this signed certificate from this certificate authority legit? And you need the signing authorities need to be installed on the host in some way, shape, or form. It's usually through your OS or your browser, and then that's how we're able to figure out whether or not the certificate is legit. But that's getting a bit into the weeds. I'm not too worried about it, and you don't have to be right now. But basically, just know you request to get a signed certificate. A certificate authority checks you out, makes sure you're legit, and then they sign a certificate and give it to you. And then that way you can tell everybody else, hey, I'm legit, trust me. And that's kind of the basis of TLS and how it works. And then we can use that that's heavily involved in the cryptography that takes place to actually make our messages unreadable by prying eyes. So just know that about certificates. Don't worry too much if it seems like a lot. You'll learn more about it as we go through TryHackMe and just as you get a better grasp of cryptography. So now down to the questions. What is the protocol name that the TLS upgraded and built upon? That would be SSL, right? So that's what we first came up with, and then afterwards we made TLS, which was better, so we switched to that. And then, which type of certificates should not be used to confirm the authenticity of a server? Okay, so the answer to this question, we didn't really go over it, but they mention it here. So they give us a couple of notes. First, to get a certificate signed, it usually requires you having to pay. However, Let's Encrypt is a certificate authority that lets you get your certificate signed for free. So that's cool. And then what they mention here is that some users create a self-signed certificate. Now, I'm sure you can imagine why that would not be legit. And you should never do that, because you really can't prove the server's authenticity, because it wasn't a third party that said it's legit, you said it's legit. So you do not want a self-signed certificate, because that really doesn't prove anything, because the whole point of TLS and the certificates is that you have this third party that puts in the effort to actually confirm the server is legitimate. So if a certificate is self-signed, then you should not trust it. So let's take that, and that should be the answer. So with that, we've answered all the questions and we're done with task 2. Now it's on to task 3, HTTPS. So here they first give us some HTTP traffic, which is a protocol that we've been over before. If you've done the prerequisite rooms, and it uses port 80 by default, it relies on TCP, and this is how we get, stuff from the internet. We send GET requests, and then the server will send us back all of this HTTP, which is right here, and then that turns into the web pages that we see. Our browser converts that. So yeah, that's HTTP, and here's what it looks like when it's not secure. We can just see everything, right? We can read all of this. Now, the way that this works, here's the actual web traffic of someone getting this web page. And so they make sure you read through everything, but they highlight it here, and I'm going to skip down to this because I think this is the most helpful for our understanding. And so what they first do is they establish a three-way handshake for TCP. And you can see that highlighted here with number 1. And so you get your SYN, SYNAC, ACK. So that's the client reaching out to the server and saying, hey, are you there? I'd like to see your web page. And then the server responding and saying, yeah, sure, I'm here. And then the second part is where they actually transfer the data. So the second part is where the web server is sending me all of the stuff to build the web page. And all of this is in clear text. That's what this is up here. We can see it, right? We can read through all that. And then this third part right here is them ending the conversation where they say, okay, I got what I wanted, great, thank you. And then they finish. So then they stop communicating. So this is kind of the 3 parts that we have of HTTP. And it very similarly follows like a normal conversation. But it's important to note that we can read all of this, and that is not secure. Now, what happens is we can add TLS to it, and then we can't read it. And what it ends up looking like is this. So this is complete gibberish, and we have no idea what it says. And that's the whole point of making a protocol secure. So the way that they do that is explained right here. So make sure you read through all this. Again, I'm going to jump down to the traffic because I think that does the best job of helping us understand. So first, they'll do a TCP 3-way handshake, the exact same as up here, right? And all that is them saying, hey, are you there? And then the server responding and being like, yeah, I'm here. But then instead of transferring data, it then says, hey, can we do this securely? And then it responds and says, yeah, sure, we can do that securely. And that second section is the TLS handshake, right? So that second part is where it actually starts the TLS session. And then this third chunk, this number 3, this is where the data is actually shared. Now, if you click on one of these and you try and read it, this is what you're going to get. Just a bunch of gibberish. And if you notice, look at the protocol type. So this is all TLS version 1.3. Occasionally you get TCP in there, but up here, this was HTTP. right? And so that's because this is now secure. Because we did this second step and we started using TLS in our conversation, now nobody can read what we're actually sharing or talking about in this third step. So that's the difference between HTTP and HTTPS. Now down here, they give you an example where they talk about the encryption key. So that has to do with how TLS actually works and how it actually encrypts our data. Don't worry too much about it, but basically, if you can get an encryption key, which is unlikely and usually you can't, but in this case, because they're the source of the traffic, they have the encryption key. So they took the encryption key and they gave it to Wireshark, which is the tool that's catching all of this conversation. And so Wireshark was then able to use that key to decrypt their conversation. And now if you look at it, you can read it again. So that's all that is. So make sure you read through this example and check it out. The big thing I want you to take away is just understanding what HTTP over TLS looks like versus what HTTP looks like. And then at the end, they show you just for fun, hey, if you actually have an encryption key, you can decrypt all of that traffic and then you can read it. And we'll actually do something with this in the final task. So you'll get a better insight into that as we do it. But okay, so that's all you really need to take away from task number 3. So now down to the questions. How many packets did the TLS negotiate and establishment take in the Wireshark HTTPS screenshot? Okay, so if we go up here, we can see, so it talks about the establishment, which is the TCP three-way handshake, and it talks about the TLS stuff. So the answer here is 8. A lot of people are probably going to put 5 because they're thinking, oh, here's all the TLS stuff, but they want us to include this three-way handshake at the top. So the answer here is actually 8. Now, what is the number of the packet that contains the get/login when accessing the website over HTTPS? So the packet, they actually have it highlighted for us, is right here. But let's look at the HTTPS one. It should be the same because this and this are the same, just one is encrypted and the other one is decrypted. So we actually need the decrypted one. We can see that highlighted there, and that is packet number 10, right? And we can see that has the get/login request. So 10, and with that, we are done with task number 3. Now it's on to task number 4. And basically this is just saying, hey, we can add TLS to other stuff besides HTTPS. We can actually add it to all of these protocols down here. And something that you probably want to have memorized is the default port number for the insecure protocol and the default port number for the secure protocol. And later in the room, they actually quiz us on this. So pause the video, take some time, try and find a way to help you memorize these numbers and which protocol they're related to. And once you've done that, you can go down to the questions and let's see. If you capture network traffic, in which of the following protocols can you extract login credentials? So the answer to that would be IMAP. And why? Because, again, if we read up here and learn about adding TLS to protocols, we would know IMAP is not the secure version. The secure version is IMAP S, which stands for secure. So if those are our 3 options, we want the insecure one so that we can actually see what's going on if we're trying to steal something. So submit that, and with that, you're done with task number 4. Now it's on to task number 5, SSH. So basically, this is just going to talk about the history of Telnet and SSH. There was a private version, there's an open source version. Pretty much everybody is using the open source version now, and SSH replaced Telnet. So yeah, just read through that and you'll get all that. But what's a couple of things that are cool about SSH is it provides secure authentication. So you can read about that. It provides confidentiality because it gives us that end-to-end encryption, and it notifies you of new server keys so that you don't have man-in-the-middle attacks. If you don't know what that is, don't worry about that. And it provides integrity. So basically, all three of those things, to sum that up, is it's secure. SSH is very secure. And that's what all that's saying. And then a couple of other cool things is SSH can create a secure tunnel to use other protocols through. Okay, and we'll get more into this later. It compares it to a VPN. If you don't know what that is, that's okay. We're going to talk about it later in this room as well. But basically, literally envision it like a tunnel. So SSH can create this tunnel for us, and we can put other stuff that's not secure through that tunnel, and then it becomes secure because it's inside that encrypted SSH tunnel. And then the last feature that they talk about is if we connect to a Unix-like system with a graphical user interface, SSH allows you to use the graphical application over the network. So in short, what that means is if we add the correct argument or flag, then we can actually use a graphical user interface on something like a Linux machine, or, like it says, a Unix-like system. So the way that works, you can read about it, but basically you probably can't see this very well. So take a look in the TryHackMe room for yourself. But up here, they SSH and they add this -x argument. And this supports running graphical interfaces. And then down here, when they type in Wireshark, they get the graphical user interface for Wireshark. So basically, to sum it up, SSH, super cool, really helpful, very secure, and other protocols can use it to become secure. So SSH is an important one. You'll learn more about it as you go through, and it's important to note Telnet was on port 23, or is on port 23, and that's insecure. And then SSH is on port 22, and today that's replaced Telnet. Nobody actually uses Telnet today. You might use it in like some TryHackMe boxes or capture the flag games, but in the real world, nobody's using Telnet. So, down to the questions. What is the name of the open source implementation of SSH? I believe that is OpenSSH, which they give us right up there. And with that, we are done with task number 5, SSH. Now it's on to task number 6, SFTP and FTPS. So you can read through all this yourself. I think it's pretty self-explanatory, but basically what they're doing here is they're just saying, hey, remember how we talked about SSH and how it can make some protocols secure? So SFTP stands for SSH File Transfer Protocol, and that uses SSH to transfer files, and that's secure. But hey, you can also use FTPS, which is File Transfer Protocol Secure, and that uses TLS, right? So now we see there's kind of multiple ways to make network communication secure. And then they explain that, SSH is a little bit easier to set up because if you want to use FTPS, you have to get that TLS certificate. Whereas SSH, you actually don't have to get that TLS certificate. They use a different method to encrypt everything and make sure that the network and your communication is secure. So read through that, but basically this section is just saying, hey, you can use SSH or you can use TLS for file transfer protocol. And that applies to other protocols as well. And then they have this view site button. So if you click on that, it'll bring up this little web page. And then it just tells you we're going to play a matching game, basically using clear text protocols to secure protocols, which is what we talked about earlier. And so like I said, you should kind of have them memorized, or at least be able to recognize them, right? So I always jump straight to 80 to 443. That's always the first one that comes to mind. And then 21, that was Telnet. So we know that that goes to 22. Oh, not 21. Sorry. 23. See, everybody makes mistakes. So 23 is telnet, and that goes to 22. And then what else do we got? We got 110, which is POP3, and that goes to 995. Where are you? Right up there. And then 143, that's IMAP, and that goes to 993. And then 25 is SMTP. I believe, yeah, that's right. 25 is SMTP, and that's going to go to 465, or 587 is the other one that it could go to. And then the only thing left is 21, and so that goes to 990, and then we get our flag. So we can copy that, we can close that, submit our flag, and with that we're done with task number 6. Now it's on to task number 7, VPN. So a VPN stands for a virtual private network, and I am just going to jump straight to the examples because, again, I personally learn way better when they just give me like examples and diagrams and things I can follow. But in order to get a handle on the diagram, especially, if you start doing TryHackMe rooms without walkthroughs or anything like that, it's important that you read. So please still read through all of this. It tells you a lot about VPNs, and it explains this setup and what's going on in these diagrams. But I'm just going to jump straight into the diagrams and kind of tell you about VPNs. So the way a VPN works is the VPN client is going to encrypt all of the data, and then the VPN server is going to decrypt it. So that's why everything in blue here is encrypted. Then once it gets past that, it's unencrypted, and everybody can use it and read it. So the two examples they give here are these remote branches of a big company. And so these remote branches, let's say they want to reach resources inside this large company, they can use a VPN to do that. And then everything traveling from the VPN client to the VPN server is encrypted and nobody can read it. Okay, so that's this. It's pretty straightforward. Again, VPN client will encrypt, VPN server will decrypt. And so everything in between is safe and secure. Now, the way that it would work with an individual, right? So this is a remote user. So let's say this is like an employee that works from home, and they need to connect to the main office resources. So what essentially happens is your computer becomes the VPN client. You download it on your computer. So if you download the VPN client on your computer, same thing happens. Your computer will encrypt everything that is traveling to this main VPN server, and then the main VPN server is going to decrypt it. Okay, so this is like an office example using like a workplace. Now, down here, make sure you read through all this. Again, make sure you read through everything in here. I'm just kind of going through the examples because I think they're the most helpful. But down here, they talk about how you can use a VPN to get around geographical restrictions and stuff like that. So this is how most individuals use a VPN. And I'm going to explain how an individual VPN works. So let's pretend in this diagram. So let's just say we're going to take away all of this top section. That just doesn't exist anymore. And we're going to take away remote user 1. We're just going to have remote user 2. So this is you at home. You don't work for a big fancy company. You don't have to VPN into their main branch server. But let's say there's a Netflix show in Japan and it's only available in Japan and you want to watch it super bad. And so someone tells you, hey, you can download a VPN and then you can watch it. So the way that works is you download the VPN client, which then means everything going to the main VPN server is going to be encrypted. Now here's what's cool. Most VPN companies allow you to pick which main VPN server you're using. So if you pick a main VPN server in Japan, what happens is you take all the stuff you're putting on the internet, you encrypt it on your computer, you send it to your router, but instead of your router sending it straight to Netflix, your router will go through the internet and then it'll go to a VPN server in Japan. And then that VPN server in Japan is going to decrypt all your traffic, and then that server sends it in clear text through the internet to Netflix. And so Netflix thinks that the person that just asked to watch this show is in Japan. But you're not in Japan, you're in the US, but the VPN server that you used was in Japan. And since it's all encrypted, right, nobody can see that traffic, and all that Netflix sees is that someone in Japan, this VPN server, asked to watch a show. And so then they send all that to the VPN server, and then it sends it back and encrypted through the internet to you. So that's kind of how a personal VPN works. So hopefully that made some sense. Read through this, that'll help you understand it. So with all that, now let's get down to the question. What would you use to connect the various company sites so that the user at a remote office can access resources located within the main branch? Pretty straightforward, VPN. Okay, so with that, we are done with task number 7. Now it's on to task number 8, closing notes. And so basically they're going to do a quick sum up of this room. So make sure you read through that. And then they give us a fun challenge. And basically to set up this challenge, they tell us, hey, we have some, well, first, make sure you start your machine and everything. I have my machine open up here. So that's my machine, and I just have that in another tab. But basically what they're going to have us do is they're going to have us upload a key to some Wireshark traffic, so some internet traffic, and they're going to have us decrypt it so that we can read it. So make sure you read through all this to have a better understanding of what's going on. But like always, I think just going through it is probably going to be the most helpful. So we're going to open up Wireshark, then we got to open a file. And this is the file that they gave us. This is a file full of internet traffic, right? I'm going to pull this up a little bit just because I like this view. So we can see here we have this traffic, and this traffic, here we see the client hello, the server hello, and then after this interaction here, which is basically where they're doing the TLS handshake, then a bunch of the traffic after that is all just this TLS stuff, and we can't actually read it, right? And there's a bunch of traffic in here. So yeah, basically if we try and follow one of these, so application data, what you can do is you can hit follow TCP stream, and so this is what we get. This is all just gibberish, right? We can't understand any of it. It stops here at the transport layer security. We can't see anything. It's encrypted application data, right? So we can't see anything. But if we follow their instructions here, what we can do is we can go to, let's go up to the top one, because they say that you can go protocol preferences. Yeah, so I think they kind of messed up here because I'm pretty sure in their instructions, first, after right-clicking anywhere, choose protocol preference, then select the transport layer security. So if I click on a TCP packet, say protocol preference, transmission control, let's say I click somewhere else, right? Then it's going to be selecting other things. So you actually do have to select a TLS packet. So then if you select that and go to protocol preferences, you can see this transport layer security. So even though they say right click anywhere, you actually have to click on a TLS packet. So right click on a TLS packet, which we did, this first one, go to protocol preferences, transport layer security, then you can open the transport layer security preferences. Now here they have a pre-master secret log file name. So basically we'll go to browse, and then we have this key. So if we put this key in there and hit OK, what'll happen is it will use that key to decrypt all of the traffic that we have. So I hit OK, and now we can see all that TLS stuff, it's turned to HTTP. And now we can actually read it. So if I go here, so this is the decrypted, and now we can actually read this, right? What are they asking for? They're asking for a GET request. They're asking for the default page. That's the path. A slash just means default. And they're asking it from, or the authority is facebook.com. So interesting, right? And we can read through all that. So now that we can actually read some stuff, and if you get here, you can just exit, because that just put a filter on for you. So you can exit to get back to all of this, right? So pretty cool. We were able to decrypt some of this, and now we can just, look around, see what's going on. Let's follow the HTTP2 stream. What are they asking for here? Again, from Facebook. This is all probably just fake traffic that they put together. I mean, not probably, it is. So now let's see, what did they want us to do? So now that we've done that, we've decrypted everything. Let's go down to the question. It says, one of the packets contains login credentials. What password did the user submit? So login credentials. So you could go through, look through all of this and try and find it. I'll give it a quick peek and see if I can do it manually. I doubt it though, because there's a lot of stuff. But if you don't want to do that, which I do not, because that seems like a lot of work, I'll go back up to the top here, and you can just, once this is selected, hit Control F. And then you have this display filter, and I'm looking for a string. What string am I looking for? Login. That's it. Okay? So as you go through TryHackMe, you'll learn more about Wireshark and how to use it. It's such a powerful tool. You can do all sorts of filters and find exactly what you're looking for. This is just a simple intro room. So I am literally just looking through all the traffic, and I'm just looking for login. And I did that by doing Control F. And so then I type in login, and then it highlights this. Okay, so there's a post, and it's posting to login. So let's follow that. Let's see, what have we got? So this is the post. Posting, authority Facebook. And then here, we can see this in red, is some actual data, right? And we have this and pass. So and pass, that stands for password. And then you have this TryHackMe, and then 7BB8 or 7BB8. Anyways, I'm pretty sure that's our password, so we can copy that. So originally you had this, right? And you might not know this, but this is encoding for that bracket, and then I didn't catch that last number, but that will be encoding for that. And you can tell that just by looking at the format they have here. If you don't know what URL encoding is, don't worry too much about it. You should Google it and get an idea. You'll run into it a lot. But once you URL decode what we got from here, right, then you'll get the flag and you can submit that. And with that, you finished task number 8. Hopefully you found the room helpful. If you did, give it a like and subscribe. That helps me out a lot. And with that, you have finished the networking secure protocols room from TryHackMe.